Welcome, my friends. Consider x squared minus 6x is less than negative 8. We want to know which values for x make this inequality true. Let's start by adding 8 to both sides to get everything on the left-hand side. We have x squared minus 6x plus 8 is less than 0. Let's factor the left-hand side. We need two numbers that multiply to 8 and add to negative 6. The two numbers are negative 4 and negative 2, so this factors as x minus 4 times x minus 2 is less than 0. Now we need to think critically about what is going on here to solve the problem. We know the zeros will be at x is equal to 4 and x is equal to 2. Those are the only two possible places where we can cross the x-axis, or change from negative to positive. Think of these values on a number line. The only time we can change from positive to negative, or vice versa, is at 2 and 4, since we have a continuous function. If we check a value for this function in each of the three regions, we should know where the function is less than 0. If we plug in something less than 2, like positive 1, we get 1 minus 4 times 1 minus 2, which simplifies to negative 3 times negative 1, which is positive 3. Since we got a positive number, any value on this side of x is equal to 2 will also be positive. Let's try something between 2 and 4. How about 3? If we plug in 3, we get 3 minus 4 times 3 minus 2, which simplifies to negative 1 times positive 1, or negative 1. We got a negative number, so anything inside this range will also be negative. How about larger than 4, such as 5? We have 5 minus 4 times 5 minus 2, which is 1 times 3, or 3, a positive number. Any value greater than 4 for x will result in a positive value for y. So there is only one region on the graph that we are less than 0, and that is between 2 and 4. So our solution is the interval from 2 to 4, and we use parentheses to represent that we don't include the values 2 or 4, due to the less than sign. You can also represent this on a number line like this. Make sure you understand why all of the values in each interval are either positive or negative. Since the zeros are at x equals 4 and x equals 2, those are the only times when the function could change from positive to negative, since we have a continuous function. So everything within each region must have the same sign. Here is the graph of the function x squared minus 6x plus 8, which is a parabola. You can see that the only time the graph is below y equals 0 is between the values 2 and 4 for x. How about this one? X minus 1 divided by x minus 7 is greater than or equal to 0. We will do something very similar to the last case. You can't multiply both sides by x minus 7, as you would be multiplying by a variable x, and we don't know if x is positive or negative, so we won't know if we need to flip the inequality sign or not. Instead, remember that for rational functions like this, where the numerator is 0 represents zeros, and where the denominator is 0 represent vertical asymptotes. The graph can change from positive to negative, or vice versa, at both zeros and vertical asymptotes. In this case, we have a 0 at x is equal to 1, and a vertical asymptote at x is equal to 7. So we set up our sign analysis chart with the values x equals 1 and x equals 7. If we plug in a value less than 1, such as 0, we get 0 minus 1 divided by 0 minus 7, which is negative 1 divided by negative 7, or positive 1 divided by 7. This is a positive number, so anything below x equals 1 will also be positive. If we plug in a value between x equals 1 and x equals 7, such as 2, we will get 2 minus 1 divided by 2 minus 7, which simplifies to 1 divided by negative 5, which is a negative number. Any values between x equals 1 and x equals 7 will be negative. If we plug in a value greater than 7 for x, like 8, we will get 8 minus 1 divided by 8 minus 7, which is 7 over 1, or 7, a positive number. That means for any values greater than 7, we will have positive numbers for this function. So the solution to where this rational function is greater than or equal to 0 is the two outer intervals, either from negative infinity up to positive 1, or from positive 7 up to infinity. We include 1 in our solution due to the greater than or equal to sign, so we use a bracket. But we can't include 7, as x equals 7 is a vertical asymptote, and we can never let x equal the value of a vertical asymptote, so we use a parentheses. Here is the graph of the rational function, y is equal to x minus 1 divided by x minus 7. You can see the 0 at x equals 1 and the vertical asymptote at x equals 7, and that the graph is positive anywhere below x equals 1 and above x equals 7. Alright my friends, that wraps up this video on solving quadratic and rational inequalities.